time and just. Yeah, if they cancel school for ice/inclement weather, it'll be the next day we come back, because it's not so much time-wise for the overall semester. We do have enough time to cover most everything we need to. It's mainly the time between now and spring break is cutting short, and it's starting to push where we don't quite have enough time. At this point, we don't have enough time to fully cover the next chapter, or not so much ACT, but before spring break, because we're pushing. It's like a day or two short at this point, which will cut it even shorter.
Yeah.
So, and at this point here, I feel that y'all should feel pretty comfortable with this here, because we've gone over it twice. And yes. In the office. They should be on the printer by the time you get there. So, guys, we're going to go on and get started with this here. Now, for the inverse, direct, inverse, or neither, I'll write these down here. For direct variation, guys, the main definition of direct variation is y equals a times x. And really, so if we have x and y on opposite sides of the equation with no addition or subtraction, and they're both in the numerator, we know it's going to be direct. We can also get the a by itself by setting it equal to y over x. We essentially divide x by both sides. Well, that's actually not any different than actually saying a is equal to x over y. It's just changing whatever the value of a is from a numeral, so 2 to 1/2 or 1/2 to 2. It's just flipping it. But all three of these here are similar versions of direct variation. Inverse variation. Y is equal to a divided by. So we have it in this version here, y equals a over x. Now we could get the a by itself by multiplying both sides by x, telling us a is equal to x times y. Now, unlike direct variation, we don't really have a different version of this, because x times y is the same as y times x. So flipping those really doesn't change anything. I wrote it for direct variation as y over x and x over y, just as the kind of way to remind y'all that's not really any different. So y equals, or here, yeah, we could say that x is equal to a over y, because really we're just comparing two variables. And in this case here, we're very set on y being the output and x being the input, but we're just saying two variables are inversely related if they have this correlation. So just because we have x and y doesn't define it in that kind of way. It's just these two variables here, how are they relating? So, looking back at these here, number one would be direct, because it does match up to our y equals a times x, or x is equal to a times y. They're the same thing. How about number two? Inverse. And there should be 5 copies there, I think. Yep, awesome. How about number 3? Neither. And the biggest giveaway is the addition sign. I'm not going to throw any of those where it's technically inverse or direct if we can just manipulate it to get, no. How about number 4? Inverse. Number 5, inverse. And lastly, number 6, neither. Neither, neither, either one. And that's all we have to do for these here. Any other questions on 1 through 6? 7 through 8. not on the test. Because it's still using those same proportions, but time-wise, I didn't really add anything. Oh, I don't. Okay. Now the next one set that we have is 10 through 13. Let's look at 13. I'm not looking at 11 or 12 because there's not going to be using grouping or cubics. I didn't include grouping or cubics into the test. But whenever we're simplifying any of these here, we're going to use our other properties of factoring. Either greatest common factor to pull out of the top and bottom, or our parentheses. Now looking at the denominator, we have x squared minus 4. X plus 2 and x minus 2. And on any of these here, I would always be looking for one that factors easiest. Whichever one that y'all feel most comfortable or can factor the easiest, do it first. Because then when we go back to the top, for this here, x squared minus 4x minus 12. Well, the negative 12 tells me that the signs are opposite. One's going to be positive, one's going to be negative. Now the factors of x squared are x and x. There's only one set of factors. Unlike the factors of 12, which are 1 and 12, 2 and 6, 3 and 4. Which one do I hope works? 2 and 6. Well, since it's a negative in the middle, most likely 6 is going to be negative and the 2 is going to be positive. And if we did check this to find the middle term, it would show us that this works. And again, the reason we want it to be 2 is either for here, well, either the x plus 2 and x plus 2 to cancel, or the x minus 2 and x minus 2. And here it worked out that the x plus 2 and x plus 2 did cancel, leaving us with 6 over. That's it. That's all we have to do for these here. So a lot of these here, especially with the multiplication division, if we need to factor them, let's use the other factors to help us actually factor it. Any other questions on 10 through 13? So we have a question over 10, 11, or 12, 13. Yeah. Now number 10, the numerator doesn't factor at all because it's a term. The denominator, we can't factor it in two sets of parentheses, but it does have a greatest common factor of x. And if we factor it out, we get 3x minus 4 left inside. And well, our x squared over x does have a greatest common factor of x, which we can simplify out, which would leave us with 2x in the numerator and 3x minus 4 in the denominator. And really, that's as far as it goes. That's as far as we can take it, because the denominator of 3x minus 4 is a single term. We can't do any simplification that way. And that's it. Any other questions on any of these here? Okay. Now the next one we have is 14 through 25. Perform the following operations. I'm not going to focus too much on 14 where we have the single terms, but I do want to look at 15. Because before we officially multiply or divide anything, it's very helpful to factor anything that's factorable. Well, the 2x is as simplified as it gets. The x minus 1 is as simplified as it gets. We can't do anything with either one of those. There's no greatest common factor. And since the degree is 1 for the x minus 1 and the 2x is a single term, we can't do anything else with them. Now the x squared minus 4, it'd be tempting to say it's a difference of perfect squares, but because of the 4x, really that x with the 4, it's not. But it does have a greatest common factor of x. If I factor that out, x squared becomes x, and the 4x just becomes 4. Okay, now that is as simplified as it gets. And what that does leave us with is factoring the x squared plus 3x minus 4. I went on and put two sets of parentheses, well, because x squared, 3x, and 4 don't have a greatest common factor to pull out. There's no common factor between the three terms. Now, since the 4 is negative, our signs are opposite. One's positive and one is negative. I'm hoping I have an x minus 1. Because if I do, I would have something in common on top and, which would mean that the other one is going to be x plus 4, because the factors of x squared are x and x, and the factors of 4 are 1 and 4 or 2 and 2. So now we can multiply these together. And as we've seen already, well, we could actually just connect the two because we're just multiplying straight across. And well, the x minus 1 and the x minus 1 will cancel out. The x and x will actually cancel out, leaving us with a denominator of 2, and the numerator would be x minus 4 and x plus 4. And that's it, because there's nothing else we can do. Any other questions on this one here? Same thing. See here. It must be just dropped off. It needs to be over 2, because we do have the 2x. Yep, I'll have to fix that. Yep. Yep, so I'll have to fix that here sometime today. Yep, that should be over 2. Any other questions on this here? Okay. Got that changed. Any other questions on these here? Okay. So let's see here. 17? 17. That second one there's going to have a denominator of 1. Now we will need to factor the numerators and denominators. Any of those that factor, well, 1 doesn't factor, it's 1. So we can look at any of these here. Almost. Got me to put 8x minus 4, because our perfect square for 16 would be 4 and 4. And so starting with the perfect squares is always a good place to start. Now we can look at the x squared minus x minus 12. Well, since the 12 is negative, our signs are automatically opposite. Now the factors for x squared are x and x. Well, the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. Exactly. X plus 3 and x minus 4. As we do want one of them to be either x plus 4 or x minus 4, it is helpful that one of them cancels, and since the middle term is negative x, we would use 3 and 4, because negative 4 plus 3 is our negative 1. Okay, now we can look at the other one. Well, since the 8 is negative, we're having plus and minus factors of x squared are x and x. Well, we already know one of the x minus 4s is going to cancel, yes? It'd be nice if one of them was x plus 4. Well, 8's factors does have 4 and 2, and 4 minus 2 does give us a positive 2, which we want. So now we can multiply them together. Well, here the x minus 4 and x minus 4 would cancel out. Here the x plus 4 and x plus 4 would cancel out, telling us that we have x plus 3 times x minus 2. And since the only thing left in the denominator is 1, we don't have to write it. However, if it had been the other way around, that the 1 was left in the numerator, we still have to include it. We still have to include it for the numerator, but not for the denominator. Any other questions on number 16? Or 17, sorry. Any other questions on 17? Any other questions on the multiplication or division? Okay. Let's move on and look at 19. With division, if you feel comfortable factoring and flipping all at the same time, you can go on and do that. But one of the biggest things you'll definitely need to make sure with the division problems is that you do change it from division to multiplication and flip the second one, so that we have our x squared plus 12x plus 20 and our x squared plus 13x plus 40. Because if you feel comfortable factoring and changing and flipping all at the same time, you can do that. Well, now we need to factor. And at this point, none of them look really nice, so we just need to pick one and go with it. I'm just going to factor the first one, the x squared minus 3x minus 40. Well, since the 40 is negative, the signs are opposite. Factors of x squared are x and x. And the factors of negative are just 40. Well, 1 and 40, 2 and 20. 3 doesn't work, 4 and 10. And then we have 8 and 5. Well, 8 and 5 is going to be the one that works. 5 is going to be positive. The 8 is going to be negative. Okay, we can drop straight down. Well, again, since 20 here is negative, the signs are opposite. It'd be nice if one of these was x plus 5 or x minus 8. So here, the factors of x squared are x and x. We have 1 and 20, 2 and 10, 4 and 5. 2 and 10. 2 would be negative, 10 is positive. Because we need to get 8, 4, and 5 don't actually work. Because we would either get x or negative x if we checked for the middle term. Okay. Now we can factor the numerator of the second expression. Well, now we are definitely looking for an x plus 10 or x minus 2. Well, since the 20 is positive, our signs are actually the same and match the middle term, which would be positive and positive. So x and x. So we're either hoping, well, since they're both positive, right? Yes, we're hoping for x plus 10. Because we can't have an x minus 2 since they're both positive. Yep. We got to flip them for division. Yep. And again, that's the big thing we got to be careful of, is making sure that we flip that second, change it from multiplication division and flip the second. Now for the denominator, since 40 is positive, the signs are the same and they match the middle term, which actually works out to be positive, we'd have plus and plus. Again, since it's just x squared, we have x and x. Plus 5 and x plus 8. Any other questions on how we got to this point here? Now, since we do have it already in parentheses, everything factored out, everything in the numerator is just really getting squished together, everything in the denominator is getting squished together. So I can really say that here the x plus 10 and x plus 10 will cancel out. The x plus 5 and x plus 5 will cancel out, leaving us with x minus 8 over x plus 2 and x minus 2 times x plus 8. And that's it. The only way that we could have simplified out any further than here is if both of the signs were opposite. So if so the x minus 8 in the numerator was like negative x plus 8, or sorry, negative x minus 8, then it could cancel out with the x plus 8. Because if both of the signs are opposite, we can factor the negative out and they'll match up. But that's it. Any other questions on this one here? Yes. And that was question 19. Yes. That's actually the next one that I had. Now with addition subtraction, we didn't do two multiplication division, or two of the division, because once we change and flip, it's essentially multiplication. Now with addition subtraction, if the denominators are the same, we can go on and add subtract the numerators. Well, with 21, the denominators for all three are 3x plus 2. It is handy. So we can go on and add here, since it's addition all the way through, we can go on and just add the numerators. So we have 9x squared, because that's the only term that has x squared. Our 6x plus 6x is plus 12x. Negative 1 plus 5 is plus 4. And this is over 3x plus 2. Now, because the denominators are all the same, we can actually just go on and add the numerators. Now, we do need to make sure that this here doesn't have any like terms on top and bottom, so it'd be good to factor the numerator. Well, if this were to work, that would mean that the 9x squared term would have to have factors of 3x. Okay, it does. And the factors of the constant term 4 would have to have constant factor, or factors of 2. Well, it does. Well, since the 4 is positive, the signs are the same and match the sign of the middle term, which actually works out to be plus and plus. Well, factors of x squared, we do have x and x. And we can try 3 and 3. Since the denominator had a 3x, we can try using 3x and 3x. And what factors of 4 would we want to use? Well, if we check this here, 3x times 2 is 6x. 2 times 3x is what? And since it's in the numerator, it would just be 3x plus 2. If it was 1 just left over in the denominator, it would be 1 over 3x plus 2. But that's it. Any questions on 21? Let's look at 22. Now for 22, obviously the denominators are not the same, but we need to get them to be the same. Now for us, the numerator x squared minus 5, I'm not going to touch, mainly because it's actually not factorable, because 5 is not a perfect square. Even if it was, I wouldn't factor it, because again, we're going to have to add and subtract, or here subtract the two numerators. So if they're like terms, they're going to have to combine. So we're going to actually need to multiply the numerators out. The denominators, on the other hand, can stay in factored form all the way down. Now the x squared plus 5x minus 14, if we factor it, well, we know the signs are going to be opposite, positive and negative. Factors of x squared are x and x. And the factors of 14 are 1 and 14 are 2 and 7. 2 and 7, 7's positive and the 2 is negative. And that works out nicely for us. Because I need the denominators to be the, yes. Because both already have an x plus 7, but only one of them has the x minus 2. So I need to get the other one to have an x minus 2 by multiplying it on top and bottom. And what that gives us is, the first one is going to be x squared minus 5 over x plus 7 times x minus 2 minus, well, the denominator is going to be x plus 7 times x minus 2. And again, we leave it in factored form just in case once we finish adding and subtracting. If there's anything in common on top and bottom, we can cancel it out. Now the numerator here, let's go on and distribute, because we do have it in a nice written form. X times x is going to be, x times negative 2 is negative 2x. 3 times x is going to be plus 3x minus 6. Now, as you can tell here, I didn't write this as one fraction because of the minus sign in the middle, because that negative is going to be applied to everything in the second set of parentheses. Now, the x squared minus 5 is not going to be affected because there's not a negative in front of it. The denominator is still going to be x plus 7 times x minus 2. But the second set, the x squared minus 2x plus 3x minus 6, the signs are going to change because of that subtraction. So we'd have plus x minus 6. So we can combine those. I put it in parentheses so we don't have to worry about changing the signs and combining like terms. But because realistically what we have is x squared minus 5 minus x squared minus x plus 6. Yes, we agree? Over x plus 7 times x minus 2. Well, here, x squared minus x squared, those are gone. That's 0. X, negative 5 plus 6 is plus 1 over x plus 7 times x minus 2. Yes? I can factor the negative out of the numerator, but would that give me something in common on top and bottom? No, it's just changing the signs. So that's it. That's as far as we have to go. And that's it. Any other questions on those there? If not, we'll go on and look at 26 through 30, I believe. Huh? There won't be one as complicated as 23 on the test with 3 terms. I was going to save this till later, but there are videos that include that one. I attached it already in Google Classroom because last year I didn't go back over it like we did this time, and I knew that that year that they were going to struggle with it like most years. So I went through every single problem on the review sheet and recorded the videos with it. I included those in a link in Google Classroom under week 8 that have all 3 videos. So if you want to go back and look at that, it is there. But it is not included on the test. So any of the ones that we skip are included there. So you can go back and look at those and get those. Now we're specifically going to look at 26 and 29 for these here. Well, looking at 26, the 2x squared, can we factor it in any way, shape, or form? Nope, so it's just going to stay that. But the 4x plus 2 does have a greatest common factor of not just 2, but 4, which would leave us with x plus 3, because the 4 factored out of the 4x is going to give us a 4. Factor the 4 out of 12, we get 3. Now we need to see what we need to do to make them be the same. Now the 4 and 2, the smallest number I can turn both 2 and 4 into is 4. As I can multiply 2 by 2 to get 4, and well, 4 is already 4. So that's the smallest number both 2 and 4 can become. What else does the 2 have? X squared, so I'm going to need x squared to get these to be the same. And what else will we need? And that is it. So that there is as far as we can go for this here, because that's the least common multiple. Any other questions on 26? So let's go on and look at 29. So we'll need to factor them as far as they'll possibly go. Now 4x squared minus 16 is a difference of perfect squares, but is 4 divisible by both terms? So we'll need to factor it out first, which would give us x squared minus 4. Well, x squared minus 4 is still a difference of perfect squares. We get x minus 2 and x plus 2. Now for our 6x squared minus 24x plus 24, it does have a greatest common factor of 6, which will leave us with x squared minus 4x plus 4. So we'd have 6 in our 2 sets of parentheses. Now, since the 4 is positive, it means the signs are the same and match the sign of the middle term, which would be negative and negative. Our factors of x squared are x and x, and the factors of 4 that we want to use are 2 and 2. Now for our least common multiple, well, for the parentheses, I know I'm going to need x plus 2 and then x minus 2, because that's coming just from the first one. What other set of parentheses would we need? We'd also need another x minus 2, because for the second one we had how many of them? 2, so for the least common multiple I'm going to need 2 of them. And since an x plus 2 did show up once, in either one we'll need it once. Now the kind of tricky part is figuring out the first number that 4 and 6 will both go into, which would be 12. So the final least common multiple would be 12 times x plus 2 times x minus 2 times x minus 2. If you wanted to write it as x minus 2 squared, that would be perfectly all right. But that's it for this here. Any other questions on these here? All right. Because that was 26 and 29. Yes. Okay, good. Let's look at 32 first, because I didn't write that one down. I only wrote 38. Actually, let's look at 38 first, and then we can come back to another one. I'll let you all pick one, because I wanted to hit 38 specifically. Whenever we look at any of these here, when solving, it is good to, one, figure out the restrictions, and most likely, if I'm remembering correctly, it's going to be blatantly obvious which ones have restrictions. because it may or may not be saying it straight in the directions. Check, hey, check for restrictions, because they might show up. And it's been a bit since I wrote the test. I do not believe any of them have a no solution. That means both solutions are restrictions. You should get at least one that works. Because for here, well, we can tell x cannot be 2 because the x minus 2. We'll need to factor our x squared plus x minus 6 to see what the other one is. Well, what I'm hoping, and would be nice if one of them was an x minus 2, because it would give us less to multiply. And it actually is. And the other one would be x plus 3. Because the 6 is negative, our signs would be opposite. Factors of x squared are x and x. Factors of 6 are 1 and 6, or 2 and 3. Well, it works out it is 2 and 3, and the 3 would be positive. And the numerator here is 5. Any questions on how we got to this point here? Yes. Okay. That's an easy fix. Got it. I have a feeling I changed it for the note sheet and did not fix it on the slides. Now, what we need to do is multiply everything by the same term so all the denominators cancel. Well, for the negative 5, I know I will need an x minus 2 and an x plus 3. Well, if we do it to 1, we're going to do it to all of them. And sometimes it's good to just start out with this here. Because I know with the negative 5, the x minus 2 and x minus 2 will cancel. Here, the x plus 3 and x plus 3 will. Now let's see what it does to the other ones. Well, with the 2, it has no denominator, so nothing's going to cancel there. And the last one, well, the x minus 2 and x minus 2 will cancel, yes? Do I have anything left in the denominators? So I found it. Because if I was missing something, we could just add it into the multiplication of all 3 and then simplify out there. Because it's a lot easier to go back and add stuff to multiply the 3 terms or all the terms by than it is to see, okay, I have too many. Now when we do that, we get left with negative 5 is equal to here 2 times x squared plus x minus 6. Now we could have done that in our head, but where did we get the x plus 3 and x minus 2 from? Right there, x squared plus x minus 6, as we factored it to get that. Okay, well, not too bad to go backwards and just put it back together. Plus, here we have x minus 3 times x plus 3. Now we do need to do some distributing. So the first one, we're going to multiply the x squared plus x minus 6 by 2 and get 2x squared plus 2x minus 12. Plus, well, we have x minus 3 times x plus 3. X squared what? Minus 9. Because if we have a difference of perfect squares, we ended up getting x, the same 2 terms, and the signs in the middle are different. Because a squared minus b squared is a plus b times a minus b. So this actually works out to be x squared minus 9. If we'd have multiplied it out, I'll write over here to the side, we would have gotten x squared minus 3x plus 3x minus 9. Really, the plus 3 and minus 3 are actually flipped, as it should have been plus 3x minus 3x. Did the same thing. But our 3x's in the middle cancel out, just leaving us with x squared minus 9. If you had not seen that works out that way, if I'd actually just multiplied them out, I would have gotten to x squared minus 9. We would have gotten there anyways. Combine like terms. X squared plus x is 3x squared plus 2x minus 21. Then we would add 5 to both sides, telling us 0 is equal to 3x squared plus 2x minus 16. Get that out of the watermark. And we get this here. Any questions on this so far? We can graph this if we wanted to, but I do know I'm going to get a fraction. Because what's the number in front of x squared? 3, because we have 3x squared. So most likely there's going to be a fraction that does occur. So if we factor this, since the 16 is negative, our signs are opposite. Well, for the factors of 3x squared, we will have x, and we'll need one of them to be a 3x. Throw it in the first one. Factors of 16 are 1 and 16, 2 and 8, 4 and 4. 2 and 8, we can do 2 and 8. And we'll check this here. 3x times negative 8 is negative 24x. Plus 2 times x is 2x, which gives us a negative 22x. Okay. We'll switch 8 and 2. Because even if I flip the signs, well, all that would have done is taken it from negative 22x to positive 22x. 3x times negative 2 is negative 6x. X times 8 is plus 8x, which gives us a positive 2x. So this here works. Well, if we have two things multiplied together to equal 0, one of them must be, so either 3x plus 8 is equal to 0, or x minus 2 is 0. Well, this one here is nice. Plus 2 plus 2. So x is equal to 2. Exactly. So that means, since x equals 2 as a restriction, we would cancel it out. Let's go on, hold on, let me finish this here, and then y'all can head out. We would subtract 8 from both sides, telling us 3x, negative 8. Divide by 3, x is negative 8/3. And again, guys, if you do have any extra ones that you're wanting to look at that weren't covered, they are right there in Google Classroom, the other videos. There are 3 of them, and they will cover everything else. But that is it that's going to be on the test. So come ready tomorrow. If we are out tomorrow, be ready the next day that we're in.